Imagine stepping out of a landing craft onto this completely uncharted, totally uninhabited exoplanet.
Okay, setting the scene.
Right, so you're walking through this desolate landscape, and suddenly you stumble across a towering, incredibly advanced alien machine.
Oh, wow.
Yeah, it's this monolith of unknown metal
Yeah.
covered in like glowing panels and bizarre geometry. So you walk up to a maintenance hatch, reach into your pocket, and pull out just a standard, everyday Phillips head screwdriver from your garage back
Yeah.
on Earth.
Right. A regular screwdriver.
Exactly. You slot it into the alien hardware and it fits perfectly. You turn your wrist and the panel opens.
That is wild.
Right. That feeling of absolute shock, that mind-bending realization that a simple tool forged in your garage perfectly dismantles a cosmic artifact. That is exactly the feeling we're exploring today.
It's a great analogy.
Welcome to this deep dive. Today, we have a massive mission. We are tackling one of the greatest, most persistent, unresolved mysteries in theoretical science.
Yeah, we really are.
We're pulling all of this from a genuinely fascinating paper by Cheng-Kai Chen titled Dual Logarithmic Spectra and the Effectiveness of Mathematics in Physics. And the core mission for you, as you listen today, is to finally understand why abstract human mathematics works so flawlessly to describe the physical universe.
Because it really is the ultimate mystery, you know? Mathematics is just this formal system generated entirely by the human mind.
Right.
I mean, we sit in rooms and invent rules, completely independent of the physical world. Yet when we take those abstract mental inventions out into the universe, they operate on the fabric of reality with just devastating precision.
They're that Phillips head screwdriver opening the alien panel.
Exactly.
Okay, let's unpack this. To really grasp the magnitude of Chen's paper, we have to start with the historical context, right? Because this isn't exactly a new frustration.
No, not at all.
Back in 1960, the Nobel-winning physicist Eugene Wigner wrote this now legendary essay. It was called The Unreasonable Effectiveness of Mathematics in the Natural Sciences.
Such a great title.
Yeah, and Wigner's entire point was that it is deeply suspicious, unreasonable, even that human math is so incredibly good at predicting empirical physics.
Right.
So for you, the listener, we are framing today's deep dive as a quest. We are looking for the universe's hidden source code.
And, Wigner's observation really came from a place of profound awe. He noticed that mathematicians would invent abstract concepts just as, like, intellectual puzzles, with absolutely zero intention of applying them to the real world.
Like just playing around with numbers.
Right. Take complex imaginary numbers. They were formalized as pure mathematical curiosities. But decades later, when physicists started developing quantum mechanics, they realized they couldn't describe the state of subatomic particles without using those exact imaginary numbers.
Oh, wow.
Or look at non-Euclidean geometry, the mathematics of curved surfaces. It was developed in the 1850s as a theoretical exercise. Over half a century later, Albert Einstein is trying to formulate general relativity.
Right, his masterpiece.
Yeah, and he realizes this purely abstract puzzle is the exact specific blueprint required to explain how gravity warps space-time.
Which means it can't just be a coincidence. I mean, if these mathematical frameworks and specific constants like pi or Euler's number or the golden ratio keep showing up in physical laws, it points to a much deeper structural relationship.
Exactly. It's not an accident.
And we also see this massive, pervasive scaling behavior everywhere in nature. Like, you look at power laws or the way fractals look the exact same, whether you zoom all the way in to a snowflake or zoom all the way out to a galactic cluster.
It's everywhere.
Right. It implies there's an underlying architectural blueprint governing how things transition from the microscopic to the cosmic. Think of it like finding out two totally different languages, say, English and Japanese, actually evolved from the exact same ancient root language.
That's a really good way to put it, because that underlying architecture is exactly what Cheng-Kai Chen's paper attempts to map. Chen puts forward a radical proposition. He argues that mathematics and physics are not independent entities that just happen to miraculously align. They are dual aspects of a single, unified framework.
A unified framework, okay.
Yeah. His thesis is that both the mathematical domain and the physical domain originate from related exponential scaling systems.
So two distinct engines, but they are built in the exact same factory and designed to interlock.
Exactly.
Well, I want to make sure I'm visualizing this machinery correctly. If they share a root structure, like if they are forged in the same factory, How exactly do they diverge into abstract math on one side, which is, purely conceptual, and hard physics on the other, which is actual stuff you can bump into?
What's fascinating here is that they diverge based on distinct, highly specific scaling generators.
Okay, scaling generators.
Yeah, the root framework is identical. It's a logarithmic spectrum. But the fundamental C, the core gear driving each domain, is different. Chen breaks this down into two specific spectra.
Right.
The first one governs the mathematical side.
Okay, let's look under the hood of that first spectrum. Chen calls this the phi spectrum. Phi, of course, being the golden ratio.
Yes.
Now, whenever we hit a complex mathematical formula in a deep dive, I always try to translate it into physical machinery for the listener.
Always helpful.
Yeah, so Chen's equation for the mathematical domain has basically three distinct moving parts. I'm not going to read out the algebra, but conceptually, think of it like this.
Okay.
First, you have a baseline magnitude shifter, which slides the decimal point up or down using powers of 10.
Yep.
Second, you have a core gear, which in this case is the square root of phi. And third, you have an index counter. It's just an integer ticking up step by step, determining how many times that gear turns.
That is a perfect mechanical translation, truly.
Okay.
Because in that setup, the square root of phi is the fundamental generator.
Right.
It is the core gear driving the mathematical domain. And when Chen actually runs this spectrum, simply clicking that integer counter up step by step, the findings are staggering.
What happened?
This single operational spectrum generates values that match over 100 known mathematical constants, with an accuracy rate mostly above 98%.
Wait, really? Over 100 constants?
Yes. It captures recursive geometric structures, continuous proportional relationships, and self-similar scaling. It basically models seamless, continuous mathematical growth.
Now, I have to push back here a little.
Sure.
Generating over 100 different constants from one single gear sounds suspiciously like an accounting trick.
I can see why you'd think that.
Right, because if I'm the listener, I'm thinking, sure, you have this core generator, but mathematical constants are radically different beasts. Pi is roughly 3.14, but other constants in math and physics are unimaginably tiny or vastly larger.
Right, the scale is completely different.
Yeah. You can't tell me one seed naturally spits out numbers on entirely different planetary scales without the math being completely rigged.
Well, the math isn't rigged, it's simply structured to account for scale. This is where that first part of the machinery you mentioned comes into play.
The magnitude shifter.
Exactly, the base 10 multiplier. The fundamental generator, the square root of phi, provides the core structural resonance. It dictates the exact sequence of significant digits.
Oh, I see.
But the power of 10 multiplier shifts the decimal point. It adjusts for the magnitude, so it does not alter the fundamental geometry of the constant at all.
It just changes the size.
Right. It merely ensures that the core structural pattern is scaled to the specific size we observe. The internal ratio remains absolutely pristine.
Okay, yeah, that makes sense. It's not changing the shape of the gear's teeth. It's just changing the size of the overall gear to fit the mechanism we happen to be looking at.
Precisely.
So if the continuous math constants are all churning out from a phi-based gear, we have to look at the other side of the factory. How does the physical universe grow its own discrete constants?
Because physics isn't smooth math.
Right. Matter is clumpy. It comes in hard, discrete packets.
And that clumpiness is the defining characteristic of the physical universe. Which leads us directly to Chen's second spectrum, governing the physical domain. He calls this the ternary spectrum.
And the machinery for the ternary spectrum mirrors the math engine almost flawlessly, but with one critical swap, right?
Yes.
You still have the base 10 magnitude shifter sliding the scale. You still have the step counter ticking away. But you pull out the square root of phi gear and you drop in a brand new seed.
The square root of 3.
Wow.
Yeah. When Chen runs the machinery with the square root of 3 as the generator, the physical universe basically falls out of the equation.
That is insane.
It really is.
Yeah.
This spectrum generates values that perfectly match the masses of all 15 standard model particles.
All 15.
All 15. We are talking about the fundamental building blocks of reality, the quarks, the leptons, the bosons, and it doesn't just broadly approximate them. The spectrum reveals distinct triplet patterns in the indexes.
Okay, let's dig into that, because when you say triplet patterns, it sounds a bit abstract, but it actually describes the exact physical reality of particle physics, right?
Yes, exactly. In the standard model, fundamental particles naturally group into families of 3, or generation.
Right.
You have the up and down quarks in the first generation, the charm and strange quarks in the second, and the top and bottom quarks in the third.
And each generation is basically a heavier, higher energy version of the last one.
Exactly. And Chen's ternary spectrum perfectly mimics this reality. As the integer counter ticks up, the resulting mass values cluster in distinct groups of 3.
Oh, wow.
The equation structurally demands the exact mass hierarchy that we observe in particle accelerators. It captures the discrete, quantized organization of matter simply by turning a gear based on the square root of 3.
Here's where it gets really interesting. Think about how these two domains contrast conceptually. The phi spectrum, the math domain, is a smooth, continuous ramp, right? It's seamlessly scaling.
Right.
But the ternary spectrum, the physics domain, is a set of discrete, quantized stairs. You are either on step 1 or step 2. You cannot hover in the empty space between the steps.
Which is literally how quantum mechanics works.
Yes. Particles exist at rigid, specific energy levels and nowhere between. But I actually have a massive problem with both of these engines.
Okay, let's hear it.
Both the math spectrum and the physics spectrum rely heavily on that magnitude shifter we talked about, multiplying by powers of 10 to slide the decimal place around.
Right, the base 10 multiplier.
But isn't base 10 an entirely arbitrary human-invented concept? Like, we count in base 10 because biological evolution randomly gave us 10 fingers.
That's the standard assumption, yeah.
Right. If we evolved with 8 fingers, we'd use a base 8 system. So if this theory claims to be the fundamental objective code of the cosmos, why on earth would the universe care about a biological artifact like the number 10? Doesn't that just prove this is a human projection?
That is the most rigorous critique you could level at this framework. And it's exactly why Chen's paper is so paradigm shifting.
Really?
Yes. Because the assumption that 10 is merely a biological accident is completely dismantled here.
Wait, how?
In the context of these dual logarithmic spectra, the number 10 is not a human invention. It is mathematically intrinsic to the relationship between the two fundamental generators themselves.
Walk us through the anatomy of that, because when I read this in the source notes, it honestly felt like discovering a glitch in the matrix. How does the number 10 emerge from these two random seeds without us forcing it?
It emerges through pure mathematical resonance. Take the core gear of the physical domain, the square root of 3.
True.
Square it. Now take the core gear of the mathematical domain, the square root of phi. Raise it to the 5th power.
Okay, I'm following.
If you multiply those two results together, mathematically the square root of 3 squared times the square root of phi to the 5th equals approximately 9.99.
Which is functionally 10.
Which is structurally functionally 10.
Wait, hold on. Let's pause there, because the implications of that are staggering.
I know.
You are saying that if you take the physical seed and the mathematical seed and you let them interact, their combined structural footprint naturally computes to 9.99.
Yes.
So the multiplier of 10 isn't just a human filing system, it's practically hard-coded into the raw materials.
Exactly. Powers of 10 emerge naturally as the synchronization point. Think of it as the ultimate gear ratio between the two domains.
Oh, man. That is incredible.
It is the resonance structure that allows the continuous mathematical engine to perfectly interlock with the discrete physical engine without grinding the gears to dust.
That makes perfect sense.
Base 10 is the natural consequence of how the square root of 3 and the square root of phi interact in a shared space. We didn't invent base 10 because of our fingers. You could argue our universe intrinsically scales at base 10, and our localized biology is just downstream of that universal architecture.
Which completely reframes how we should think about information processing at a cosmic scale.
Absolutely.
Because the paper introduces this concept of a logarithmic binary system. Now, when we typically think of binary systems, we think of modern digital computers, right? We think of the literal matrix.
Right, a linear additive space built purely out of discrete ones and zeros.
Exactly. But instead of building the universe with digital ones and zeros like in the Matrix, the universe is doing logarithmic addition like turning the volume dial up one notch at a time on a cosmic soundboard, where the two fundamental tones are the square root of 3 and the square root of phi.
And we really need to clarify what logarithmic addition actually means in this context, because it behaves very differently from linear addition.
How so?
Well, in a standard digital system, if you want to build complexity, you just line up ones and zeros in longer and longer linear chains. 1 + 1 = 2. It's additive.
Right.
But reality operates in logarithmic space. The fundamental mathematical rule here is that the logarithm of a base number raised to an exponent is equal to the exponent multiplied by the logarithm of the base.
Meaning that when you turn that dial up just one single notch, When you increase the exponent by 1, you aren't just adding a single block to a pile.
Exactly. You are adding a whole new logarithmic term. It is fundamentally an additive process on the back end,
Yeah.
but because it occurs within logarithmic space, the real-world output is massive exponential scaling.
Wow.
Yeah, this simple additive counting mechanism generates the immense cascading complexity of the physical universe.
This raises an important question, though. We've established these two fundamental tones, these two seeds. We have the raw materials of mathematics and the raw materials of physical matter.
Right.
But the universe is not just a static museum of constants and masses. It's dynamic. Things crash into each other. Stars ignite. Galaxies collide.
Sure.
So how do these two engines actually communicate to create movement and reality?
Well, if the generators create the raw materials, there must be an operating system that governs how they interact.
Yeah.
And in Chen's framework, that operating system is what we historically call physical laws.
Wait, so gravity, electromagnetism, thermodynamics, they aren't just invisible forces pushing matter around.
No, and this requires a profound redefinition of a physical law. We usually think of physical laws as descriptive rules of behavior.
Right, like rules written on a cosmic whiteboard.
Exactly. But under the dual logarithmic spectra framework, physical laws are structurally vital pieces of the machine. They are invariant bridge relations. They are the actual mathematical mapping connecting the phi spectrum to the ternary spectrum.
Oh, I see. They're the drive shaft connecting the mathematical engine to the physical wheels.
Yes.
And the paper highlights a very specific pattern to describe this, the 2+1 organizational structure, which significantly is a pattern deeply embedded in the standard model of particle physics as well.
Yeah, the 2+1 structure is really the elegant summary of the entire framework. The 2 represents the foundational pair, the
Right.
fundamental generators, the square root of 3 and the square root of phi.
Right.
But those two seeds cannot function in a vacuum. They require invariant equations to mediate their interaction. The physical laws constitute that vital +1 component. You have the mathematical seed, the physical seed, and the laws that bridge them.
So, if physical laws are just the structural bridge between a continuous math spectrum and a discrete physics spectrum, does that mean every power law we observe, every fractal we see in nature, from the jagged shape of a coastline to the branching of human blood vessels to the spiraling distribution of galaxies, is literally just a shadow cast by this underlying logarithmic machinery?
If we connect this to the bigger picture, the answer is an overwhelming yes.
That is just wild.
Scale invariance, fractals, the way nature relentlessly repeats its structural patterns at every conceivable magnitude. These are not random aesthetic quirks. They are the natural, unavoidable physical consequences of a reality operating on a shared logarithmic foundation.
So the universe has to look like a fractal.
Exactly. It has to look like a fractal because its underlying source code is logarithmic. Mathematics continually appears in empirical physics because they are born from the exact same architecture.
So what does this all mean? Let's bring this all together for you. We started this deep dive, stranded on an alien world, staring at an incomprehensible machine, only to realize that the simple human tool in our pocket was perfectly designed to unlock it.
Right.
Through Chiang Kai-chen's work, we've basically solved Eugene Wigner's 60-year-old mystery. The universe isn't just a random collection of clumpy matter that accidentally happens to follow the rules of human math.
Not at all.
Physical reality and mathematical structure are dual aspects of a single beautifully synchronized system. A logarithmic factory built entirely on the interplay of two profound seeds, the square root of 3 and the square root of phi.
Beautifully said.
Human math works because when we do math, we are reverse engineering the very gear mechanisms that built the stars.
It really forces a complete reassessment of our position in the cosmos. We aren't just passive observers mapping the universe with arbitrary symbols. We are actively uncovering the structural resonance of reality itself.
Absolutely.
But I want to leave you with one final thought to ponder, drawn directly from the future work section of Chen's paper, and it is truly staggering.
Oh, hit me with it.
The current framework operates flawlessly on these two fundamental generators. But Chen suggests the necessary next step. We must test whether additional fundamental generators exist out there in the mathematical ether.
Meaning beyond the square root of 3 and the square root of phi.
Yes. Think about the implications of that. If our entire known physical universe, every particle, every galaxy, and every mathematical concept we have ever conceived is just the output of these two specific generators interlocking, could there be a third seed?
Oh, wow.
Or a fourth? And if another generator does exist, what kind of reality or dimension would it build? It would likely construct a reality so profoundly alien, operating on completely different structural laws, that we wouldn't even possess the mathematics or the physics to perceive it.
Imagine finding that alien monolith, turning the screwdriver, and as the panel opens, you realize the tool in your hand is just one of an infinite number of tools in an infinite number of shapes required to truly understand the machine. Thanks for joining us on this deep dive. Keep questioning the code.